So when your input is 0, at that time the circuit work as a open loop amplifier. Why open loop amplifier? Because capacitor works as an open circuit. तो आप यहाँ से ओपन सर्किट में यहाँ पे आप एक कैपेसिटर निकाल दोगे फीडबैक में से. If you remove this capacitance, then the circuit work as a open loop amplifier. And why this capacitor work as an open loop amplifier, open circuit? Because this due to this input offset voltage EIO. Okay, so when this there is no input, there is no control over gain, because in open loop configuration our gain is constant 2 into 10 raised to 5. So how can we overcome it? We can, and when there is no control over gain, we can say it has the no stability. So what we are going to do, when your input is 0, I do not want to make this circuit open loop amplifier. So what we are doing here, this practical integrated circuit along with this CF, we are connecting this resistor RF. What is the use of this RF? Can you now tell me when your input is 0, does your circuit works in open loop configuration or in closed loop configuration?
Closed loop.
It works in the closed loop configuration, because for input 0 your capacitor works as an open circuit, but now you have this resistance RF, so its gain remains constant minus RF by R1. Your gain should not reach up to 2 into 10 raised to 5. Okay, so this resistance RF overcomes the problem of basic integrator. Which type of problem? Stability problem, and it won't try to open into open loop configuration. Okay, so we have in your textbook the graph of frequency versus frequency versus gain is given. Can we go through it, or can you do it yourself? आपके बुक में एक ग्राफ दिया है, हाँ तो आप देख लेना from that graph these two equations are written, F3 and Fa. F3 is 1 upon 2 by R1 CF, and Fa it is 1 upon by RF CF. Okay, and generally this Fa should be less than Fp. Fp is the unity gain bandwidth, and Fa it is the gain limiting. If you are asked this question in the form of shortcut, तो आपको पहले basic integrator draw करना है. Derive this formula. Draw the input-output waveform for sine and square wave. Then you discuss this limitation, and after that you draw this practical integrator circuit. Okay, and in practical integrator circuit, it is remember this designing steps. We always select this Fs should be less than Fp, and we take, for the example, if we take Fa is equal to Fp by 10, then using this formula you can say your Rf should be 10 times R1. इसमें have to remember only these three formula. Then you can design this integrator of any required frequency. Okay. Now next one is differentiator. The operation is opposite to the integrator. यहाँ पे integrator में हमने क्या किया था? We have taken capacitor in feedback. Okay. Now in differentiator we are taking this here in place of R1 and we move this R1 as a feedback resistor. So when we go study for signal and system,
28, 29, 30.
for signal and system you use your dot and dot only read this read the example. All each example yourself. Now tell me the steps to find out the output formula. How will we derive the output formula? Output is formula.
By applying KCL.
चलो KCL अप्लाई करोगे तो क्या आएगा? IC is equal to
IF plus IB2.
okay. Then next, what we have to assume?
IB2 plus
So my IC is equal to IN. Now what is the formula for IC? Collect capacitor correct? Is C
AD by B2.
okay. IF is V2. This is V2 minus VO by RN. Okay. And then capacitor voltage it is VE minus V2. Okay. Here it is V2 minus. Okay. Now take V2 0. So your output formula it is minus RF C1. Here you put C1 because we are going to connect the resistor, capacitor and resistor in practical integrator circuit. So what is the relationship between input and output?
Output is differential and output.
Output is differentiation of input. Okay. So when you give sine wave, you are going to get what is the output? Sine का differentiation क्या? Cosine मिलेगा. Okay. And when you give square wave, the square wave का differentiation क्या मिलेगा? Sine मिलेगा. When you have positive positive input, you have the negative spike. When you have negative input, you are going to get positive spike. Why it is that? It's to this negative sign. Okay, let me just draw here the output and waveform for a square wave. Then here negative 5 or minus 4. Then again this reading constant, but when your input is from plus 1 volt to minus 1 volt, you have here spike of such spike. Okay, so this is a output voltage. This one is a okay. Now, what are the limitations of this circuit? If we consider the gain of the circuit, so this is basically inverting amplifier. So in inverting amplifier, instead of C1, if resistor is there, what is the gain of this amplifier circuit?
Minus red by R.
Minus Rn by R. Okay, but here instead of R1, we have capacitor. First is let us say gain. Okay, so my gain is minus Rn by Xc1. We have to consider instead of capacitor, we have to consider reactance of this R1. We have to consider reactance of this capacitor, and this reactance of this capacitor, it is 1 upon 2 pi Fc. Okay, so as I increase the frequency, what will happen? The gain of this differentiation is going to be increase or decrease. As we increase F, what will happen? X is going to be reduced, and this gain is going to be increased. Okay, so we can say there is this gain doesn't remain constant. As your frequency increases, the gain also increases. Second one, if I consider the input impedance, then in voltage and amplifier RIF, it is R1, whereas in voltage series feedback amplifier we use it is R1, it is RI into 1 plus A beta. Okay, that we have derived. And this is for voltage surge feedback amplifier. RIF is R1, whereas here instead of R1, what we have connected? We have the capacitor. Okay, so what is the input impedance here? RIF. It is simply reactance of the capacitor. Okay, so what will happen as the frequency increases? The reactance, this resistance is going to be increase or decrease? Decreases. Okay, so this input resistance is going to be decreased or reactance is going to be decreased. What does it mean? This circuit is susceptible to the noise. Why it is affected by noise? Because what is the frequency of noise? It is high frequency. Generally, noise is high frequency signal. Okay, for high frequency signal, capacitance reactance is very low. So what will happen? Does it pass through this capacitor, or this capacitor blocks the noise? Are you getting my question or not? Noise is always a high frequency signal. Okay, so what is the reactance by this capacitor to this high frequency signal? Does it allow this high frequency noise, or does it block this high frequency noise? It will allow to pass the high frequency noise. What will happen? Sometimes, if possible, your noise may override the differential output signal. Our output totally noise is signal as well. Although if you have given this input and some noise is there, then this noise can easily pass through this capacitor, and if possible, you get totally the noise signal. The noise signal has completely override the select this R1C1 is equal to Rf. This is gain limiting frequency. And whenever we want to design the differentiator, next to this, draw here the response. Let us go here to you what is FA, FP, and FC. How many students are present right now?
7.
Out of the 17, one is myself and second one is I am presenting the screen. So effectively, which students are there? No problem. So, student first let us consider this is the plot of gain, where gain is given in decibel. Okay, and this is the frequency. FC is the frequency at which your gain is unity. Unity means 0 dB. Okay, 0 dB is equal to absolute value 1. Okay, so here FC it is unity gain bandwidth. Now, if we do not connect, see, if we consider the basic integrator means with only RF and C1. Okay, then this one, as in the basic integrator, as you increase the frequency, we have seen as we increase the frequency, gain is going to be increased. Okay, so here what will happen? The gain is going to be increased and it approaches the open loop response. This is the open loop response of this IC741. Whereas this one, it is response of basic differentiator. Okay, but now when we connect this feedback capacitor CF and R1, then what will happen? Up to some frequency, your gain is going to be increased, and after that, it starts decreasing. Okay, so this is let us say that this F, this point at which gain is again unity gain, it is F gain, and the frequency after which this gain starts decreasing, it is called as a FB. So FB is 1 upon 2 pi R1 C1. FA, it is unity gain bandwidth. It is then F. Student, remember the scale is not starting from 0. It is some reference frequency F. So all these values are in terms of F, tan F, tan square F, tan F, and so on. So when you want to use this circuit as a differentiator, then in which reason you will operate this circuit? क्या reason में operate कर सकते हो differentiator करके work कर सकते stable differentiator. And frequency range से कई ले सकते हमारे differentiation output is a differentiation of input. Between you should operate your differentiator in this range FA and FB. FB થી આગળ જશો તો તમારી સર્કિટ અનસ્ટેબલ થઈ જશે, gain becomes very high. Okay, this is the practical differentiator. And how will you select this frequency? This FA should be less than FB and FB should follow these two steps